While Russia is improving the characteristics of its Su-35 fighters and perfecting the sole fifth-generation Su-57 which debuted last year, the United States is laboriously developing sixth-generation fighters, proving to be one step ahead of the competition. The technology of the sixth-generation aircraft is currently so novel that it could be described as magical, and U.S. foreign policy strategist and procurement assistant to the U.S. Air Force Secretary Will Roper used the same word to describe it, being the most advanced level of fighter craft to date if we take the world's progress into account. Is this description of the F/A-XX crafts as magical accurate, or is it merely a bluff to terrify its opponents? To answer this question, one would need to fully comprehend this new generation of aircraft, beginning with the development plan and onto the actual technologies involved. The Next Generation Air Dominance (NGAD) program, also known as F/A-XX, has been under development of the U.S. Navy Command for several years. A separate office was even commissioned by the U.S. military for its research and development as part of the program. The goal of the program is to create a new carrier-based fighter to replace the F/A-18 Super Hornet 4th generation fighter jet and the EA-18G Growler electronic warfare aircraft. Both these aircraft are in service with the U.S. Navy and Australian Air Force. While these are excellent planes, they are gradually becoming obsolete as other countries seem to be making progress with more advanced aircraft. And so, a new sixth-generation multi-purpose bomber is being developed for the U.S. Air Force as part of the secret NGAD project. However, the U.S. Navy may be able to obtain these super fighters before the Air Force. This is an intriguing feature given that, unlike the Air Force, stealth is not an important consideration for Navy aircraft carrier aviation because its fighters are not meant to infiltrate hostile airspace. As a result, the nature of the combat missions of naval fighters and Air Force fighters differs, and their aircraft will have distinct needs. This poses the issue of how both of these needs may be addressed inside a single project. In the words of Roper, by magic. In reality, this means that the U.S. will be adopting a new strategy of technological flexibility, or as the Russians called it, technical uncertainty. The course of the NGAD program and all of its technical intricacies are, of course, strictly classified information. But Roper identified that this technological flexibility will be mostly dependent on digital engineering, software, and open architecture of digital space that simulates real-life conditions. This program serves to be a response to the Russian concept of critical technologies, which created the Zircon hypersonic cruise missile. Because Americans are great executives and experts in project management, the prospects of this program are certainly bright. Consider the creation of the Boeing T-7 Red Hawk trainer when they implemented a unified virtual simulation process, a model in which the craft is first created and tested in virtual space, and only after that is it embodied in hardware. This same approach is applied in the creation of the sixth-generation fighter, as well as a multi-stage competition model similar to the one used to invent the reusable manned spacecraft commissioned by NASA, which is intended to motivate engineers and speed up the progress. This competitive race, so to speak, has some U.S. leading aviation manufacturers like Lockheed Martin, Boeing, and Northrop Grumman Corporation participating currently, and it's expected that some other companies will be recruited along the way, including Elon Musk's SpaceX team for some military equipment. Lockheed Martin is well known for their development of the fifth-generation F-22 Raptor and the F-35 Lightning II fighters, leaving no doubt about the qualifications of this group for the program. While the Boeing company is not ahead in the space industry, they have substantive experience in the design of supersonic UAVs, which strengthens their competitive positioning in the program. The Northrop Grumman Corporation was the first to introduce the Flying Wing Service. Their B-2 Spirit Bomber and RQ-4 Global Handle drones are in active service of the United States. Their competence in UAV creation also strengthens their stand in the race, as this is an important criterion in this new generation of fighter aircraft. Regardless of their qualifications, though, will these three aviation tech giants manage to satisfy the demands of the military on this program? The NGAD program for sixth-generation fighter aircraft have some criteria that must be met, ultimate stealth being the most important of them all. Based on the Northrop Grumman stealth technology, there are two common methods of escaping enemy defenses in the modern world, and they include using stealth or using hypersonic speed. American military seems to favor stealth over hyperspeed, unlike countries like Russia or China. But the 6th generation of fighters will turn the game around, as these new aircraft should be capable of achieving stealth at supersonic speed mode. Another criterion for this new generation of warplanes is efficiency in all flight modes, from subsonic speed mode to hypersonic speed in unmanned flights. The U.S. has declared that the maximum speed of the fighter will exceed Mach 5, and the flight range will be up to 30 hours in subsonic unmanned cruising mode and supersonic cruising. The combat radius will be 1,600 kilometers. This does not comply with the capacities of existing technologies today. The fact is that it's currently impossible to go on stealth mode at speed over subsonic. The infrared spot of a light reaches the size of an aircraft during the engine afterburn, making it visible to enemy radar. The stealth aircraft also has to have smooth outer contours with a minimum of sharp edges and no vertical tail. So far, there is no single hypersonic craft or UAV in the world without a vertical tail. The tail serves to stabilize the object on the move at super speed. This then makes the third important criterion for the 6th generation fighter planes, the ability to change the aircraft's shape. The fighter must have two distinct features: to remain invisible and to maintain the highest speed of acceleration at the same time. The materials of these new fighter planes will also be different. The outer plating must calmly and repeatedly withstand hypersonic loads. Under such conditions, the heat generated may cause some of its mechanical properties to melt or soften and become unreliable. The technology to withstand such pressure does not exist like on SpaceX's spacecraft that is exposed to no less stress. However, a rocket differs from the fighter in combat in that while the rocket will be mounted for maintenance after every successful landing, the fighter plane does not have such an opportunity. The fighter aircraft must be ready for several combat missions in a row. Super sensitive electronics would also need to be put under the plating, and the high temperatures included in hypersonic speeds are not recommended for it. These electronics cannot be done away with though, because without them the fighter is blind and vulnerable. This generation of fighter jet also features a power plant that accelerates the aircraft to incredible speeds and allows maneuvering in several planes using a controlled thrust vector. Weapons of the fighter planes of this new generation also begged a question. It has been declared that the F/A-XX will be equipped with directed energy weapons, a laser. This was confirmed in the public information released from the U.S. Air Force's laboratory. Unfortunately, detailed information concerning the characteristics of this laser was not included. The only detail of the program that was not kept under a tight lid was the business model of the project, and it is a breakthrough in the American traditions of project management. While the development is competitive among several companies, at a certain stage, all the developers of the fighter planes will unite in one structure. This will greatly reduce the cost of the project and improve communication among specialists. The participating companies will join forces at the stage of digital design and virtual assembly. This business model will operate right up to the physical implementation and prototype production. This is particularly incredible, as previously competing companies did not seek to share their technical know-how, but will now be willing to change this in the interest of the safety of their home country. This synergy can deliver the highest results and the most unexpected technical innovations in the field of materials, avionics, propulsion, and weaponry. The creation of such a jet that fulfills all these criteria naturally would take 20 years, but if the process is well funded and the best engineers are involved, then the timeframe will surely be shortened. It is expected that the first one of these aircraft will take to the skies around 2030. While we await results from the U.S. military engineers, it is significant to note also that France, Germany, and Great Britain are working on similar projects, while Russia and China are notably trying to achieve parity in other areas of their military. Let us know in the comments section below what you think combat will look like in the future as a result of these recent advances.